Today we're going to have a look at energy systems or energy pathways, and we need to know about them because they are the ways that we resynthesize ATP. So recapping, remembering that ATP is our adenosine triphosphate. That is broken down into adenosine diphosphate. So there are two phosphate molecules and a loose one. And that breaking of the bond here is what provides us with the energy. So that energy here is used for muscular contractions, and we use that to make our movements. So for us to be able to continue making energy, we need to resynthesize this ATP, which means join it back together so that we can continue with this process and continue to make energy. So the important term to remember there is ATP resynthesis. Okay, that's a good one to keep in the back of your mind for subject-specific terminology. Okay, so for ATP resynthesis to happen, we need to get energy from another source to make this link here happen. So we need some form of energy to help us do this part here. There are three ways that our body does that, so three energy systems, and the first one that we're going to have a look at is the ATP-CP system. So that may also be called the ATP-CP system, or it might be called alactacid or the phosphagen system. Now, this system works by using creatine phosphate. So creatine phosphate is stored in the muscles. It's a molecule of creatine and a molecule of phosphate. So as we know now about breaking of bonds, when this bond breaks, it produces energy. And we can use that energy to resynthesize ATP. Now, stores of creatine phosphate in the muscles are pretty limited. So there's only about 10 seconds worth of activity or energy of creatine phosphate in your muscles. This system is also only used for high intensity, so maximal intensity, short duration work. So anything that's up to about 10 seconds. So you can imagine a sprint or the long jump. Or it might not be just the 100-metre sprint, it might be with a sprint within a game of netball or a lead for the ball within a game of football. So even though there's only 10 seconds worth of stores in your muscles, the positive is that it takes not very long for it to resynthesize, so to replenish. You can get about 50% of your creatine phosphate back within 30 seconds, and then 100% of it is restored after about 3 minutes. So once you do that one effort, it doesn't take very long for it to recover and for there to be more creatine phosphate ready to go. Another positive about this system is that there are no byproducts that will inhibit your performance. So there's no lactic acid that's formed. The only limitation to this system is the availability of it in the muscles. The next system that our body uses to resynthesize ATP is the lactic acid system, also known as the anaerobic glycolysis system. Now, we should remember that anaerobic means without the presence of oxygen, and glycolysis means the breakdown of glycogen. So remember that comes from carbohydrates that we eat. So in this system, we're going to be using glycogen as the energy source to resynthesize ATP. When glycogen is broken down, it releases energy, which we use to resynthesize our ATP. However, when glycogen is broken down, the leftover product is called pyruvic acid. Now, if pyruvic acid doesn't have any oxygen available, it turns to lactic acid. And we know that lactic acid, if there is a build-up in our muscles, then that is what causes the feeling of fatigue and forces us to reduce our intensity of exercise. So the lactic acid system is used for short-term and higher energy activities, so maximal intensity, high intensity of up to approximately 2 minutes, because after that the blood lactate or the lactic acid is normally going to be building up too high and will cause us to feel muscular fatigue. What happens when we've got too much lactic acid? We need to reduce our intensity so that we can get more oxygen to help clear the lactic acid from our muscles. So some benefits of the lactic acid system: it's very quick acting because it doesn't require oxygen. So there's nothing that needs to be broken down, it's very quick. Some negatives though are obviously the byproduct of lactic acid and that it only lasts for up to 2 minutes. So the third and final energy pathway or energy system that our body uses is the aerobic system, also called the oxygen system or aerobic glycolysis. And again, we remember aerobic means with oxygen, glycolysis meaning the breakdown of carbohydrates, or breakdown of glycogen rather. The aerobic system can also be used for aerobic lipolysis, which is the breakdown of fats, but remembering that when we're doing activity, preferred energy source is glycogen because it's quicker to break down. So once again, we're using glycogen to break down and produce us energy, and then that's going to be used to resynthesize our ATP. Again, the byproduct here is pyruvic acid. However, this time we do have the presence of oxygen here. So because we do have oxygen, there's a process that happens in the mitochondria, which means that the pyruvic acid moves into what we call the Krebs cycle. We don't really need to know too much about that, but basically the Krebs cycle helps us to produce more ATP, so 36 more molecules of ATP actually. So this whole system does produce us the most amount of energy in the quickest amount of time. So aerobic system, because it requires oxygen, it means that it's mostly used as the dominant energy system in sub-maximal activities. So that means that are not as high intensity, and for anything that continues for longer than 2 to 3 minutes. It's also the most dominant energy system in recovery. So say you've done your 100-meter sprint, immediately after that you are using the aerobic system to recover. Positives of this system are that it can be used for a long time. There are no fatiguing byproducts. There's no lactic acid buildup from the aerobic system, and there's nothing that's going to stop you from performing. And it can also, the other positive is that it actually can break down all 3 of the fuel sources this way. So carbohydrates, fats and protein in extreme circumstances, but obviously our preferred one is carbohydrates. Some negatives are that it needs oxygen for this system to work, which takes time to get to the muscles. It's only dominant during submaximal activity, so not good for anything with a higher intensity. The important thing to remember though is that all 3 of the systems do work together. So you've got all 3 of them working at one time. So it's not that your body's only using the aerobic energy system at the moment while you're sitting here. The other 2 are still contributing some ATP, just not as much as the other. And also when you're doing the sprint, your ATP-CP system might be contributing the most, but the other ones are also still working in the background. We call this the interplay of energy systems, and that's going to be something really important to talk about in your assignment. Okay, so that's all for today. So if you want to check the textbook, these diagrams are similar to what is in there. Theirs are obviously a lot neater than mine, and you can read more about them there. I also would like you to answer all of the focus questions related to this topic. So in topic 1, and the focus questions for each of the energy systems.